Video shows the Woggles as of the 1992 AAAI exhibition. This is a rough tape just to get them down on record so people can see what we're working on. So this is a 3D world modeled as there's a plane with a height field defined over it. The creatures can see those heights. They can't see the colors that we've painted on the height field, but they can see the shape of the world. Inside of that space, there are three autonomous creatures, the orange one in the upper left, the blue one, the red one, that are controlled by instances of the TOC agent architecture. And then there's a purple one which represents the user in this space. So three autonomous creatures use this architecture which provides goals, reactivity to the environment, and a model of emotion, which we'll talk about more a little later. So this purple one is me. I can jump around in the space, and I can interact with these creatures. So I'm going to try to get the attention of one of them. Maybe this red one, if it's willing to listen. And it is willing to listen. So I did a greeting to it that was a certain kind of stretch vertically. And it greeted me back, which meant that it was willing to follow the leader. So as I jump around, it's following me around. So it's watching my actions, and it's trying to mimic them. Okay, now I'll tell it that I want to quit. That's the hey, and now I think it knows to quit. Yeah, so it's going off on its own now. Now I'm going to come and bother this red one. That swelling up, that expansion, is a threatening gesture, but it's too asleep to pay attention. There, that woke it up. So it's threatening me back, and I'm going to run away. So the blue one and the red one decided to dance on these pedestals that we have. And this little orange one, Shrimp, is afraid because Wolf, the red one, got near it, got too close to it. It's afraid of Wolf. So I'm gonna come over here and threaten it myself. So you can see it running away, and the blue one, called Bear, comes to protect it. Oops, come over here. Now, Wolf, I think, ganged up with me against Shrimp. So the blue one's trying to protect Shrimp from both of us. So Bear's having a tough time. So now I'm going to get Wolf. I think Wolf is scared. Too many people have been attacking him. Now Shrimp's coming down here to go to sleep, probably. And it looks like Bear's coming down to join him. Join it. Bear and Shrimp like each other, so they often sleep close to one another, but so Wolf is going to bother them both, probably. Shrimp might wake up. You can see Shrimp sort of trembling back here. He's scared that Wolf's there, but he's not scared enough to do anything about it. So I'll start some trouble. Okay, let's look at what's inside of the creatures, the minds of the creatures. So we can bring up a kind of an EEG panel. This orange line means that this is the description for shrimp, the orange one. This is the description for wolf. This is the description for bear. And up here we have information tracing over time the state of certain internal information that's also displayed on those panels to the left. If we look over at shrimp, say, we can see that this orange indicator here is the number of milliseconds taken per frame, per video frame, for the brain of shrimp to do its thinking. And it's bouncing up and down. I think the max here is 30 milliseconds. This green indicator is the number of goals active on a scale from 0 to 100. So if you look over here, this green line is working its way up, and then it dropped. That's 100 goals down to maybe 70 or 80 goals active in the plan, in the goal tree of that character. This red line, which is diminishing with time, if we come back, we'll see that that's the, probably it's the level of being alarmed. So there are four, besides this standard just sort of internal information, there are four emotions that are shown here: happy, sad, angry, and afraid. And right now shrimp doesn't have any of those because shrimp is sleeping. But these emotions are derived from goals that shrimp has in the action side of the architecture. If shrimp is trying to achieve an important goal and that goal gets achieved, shrimp will tend to be happy. If the goal fails, shrimp will be sad. If someone causes the failure, shrimp will be angry. And if there's an important goal which shrimp judges likely to fail, shrimp will become afraid. And those raw emotions get translated into four styles of behavior: cheerful, glum, aggressive, and alarmed. In a typical creature, happy will produce cheerful behavior, and angry will produce aggressive behavior, and afraid will produce alarmed behavior. But if you change that mapping, you can add some personality to the creature. So in the case of wolf, afraid as well as angry produce aggressive behavior, and alarmed behavior rarely appears unless the level of fear is very high. These features, behavioral features, then influence what goals get selected and what plans get selected to implement those goals. And in dark lettering here, there are a number of goals listed, such as wander or watch another woggle. So wolf, let's see, so bear now is doing lead in follow the lead, and wolf is doing dance on pedestals. So you can see wolf down here dancing on the pedestals. Shrimp is going somewhere to watch the other woggles, and you'll see he turns around and he watches, it's hard to tell, maybe it's bear now. So the styles of behaviors, the features, help determine what goals, what top-level goals, or what top-level behaviors are in effect at any moment. And those goals in turn influence the emotions, which influence the features. And so there's a feedback system between action and emotion. These purple lines tell how many sensors are active at any moment. The goals are constantly being monitored for premature success or failure. Usually a goal succeeds when some behavior that it's invoked succeeds, and it fails when there's no behaviors available to make the goal succeed. But those goals are monitored, and part of the way they're monitored is to watch events in the world. These purple lines are tracing how many simultaneous events are getting monitored. So as the goals increase, you tend to see increases in the number of sensors that are active. So the system's doing selective sensing based on the currently important goals. I think they got tired. The shrimp's trying to get Bear to play. Bear's asleep. So it joined him.